Energy, right? It's the absolute key to global development and prosperity. You could honestly say that the entire economy is just energy transformed. But right now, we're facing this urgent kind of hidden crisis in how we actually get that energy. The efficiency of finding and extracting oil, it's in a vertiginous freefall. We're literally working harder, spending way more, and getting significantly less out of it. But what if the solution isn't drilling in the freezing Arctic or throwing billions at uncharted frontiers? What if massive, totally untapped reserves are hiding right under our feet in fields we honestly thought were completely empty? In this explainer, we're going to unpack a revolutionary scientific breakthrough that is completely flipping the script on global energy economics.
So, here's our roadmap for today. Number 1, the decline of EROI. 2, the limits of seismic. 3, the RSS-NMR revolution. 4, the treasure of mature fields. And 5, smart acquisition strategy. We are going to journey all the way from macroeconomics straight to a brilliant corporate acquisition masterstroke.
Okay, let's dive into this with Section 1, the decline of EROI, working harder for less energy. So the fundamental mathematical problem facing modern oil exploration really boils down to one absolutely crucial acronym, EROI. That's Energy Return on Investment. Now, you might usually think of ROI as a purely financial term, right? But in the oil world, it's a physical measurement. It simply asks, how many barrels of energy do we get back for every single barrel of energy we have to burn to find it, drill it, and pump it out? And really understanding this ratio is the key to understanding why traditional exploration is becoming dangerously unsustainable.
Historically, we've seen a massive, massive plunge in this ratio. Back in the 1930s, during the golden age of easy surface oil, the EROI was an incredible 100 to 1. I mean, you practically stuck a pipe in the ground and it gushed. Energy was virtually free. But by the 1970s, as we transitioned to deep offshore and had to build these massive platforms, that dropped 30 to 1. Then in the 2000s, as the giant fields declined and non-conventionals arrived, it hit 15 to 1. And today, the global average for conventional oil is hovering around just 10 to 1. And for non-conventionals like shale, it's a dismal 3 to 1 or maybe 5 to 1. Basically, traditional greenfield exploration, starting from scratch in new territories, has just become unbelievably expensive and energetically inefficient.
Section 2, the limits of seismic. Blind pioneers and blurry shapes.
See, for the last 60 years, the industry has essentially been hunting for oil while wearing the completely wrong glasses. Back in the 1960s, 2D seismic technology gave us what we call a curtain effect. It only showed these vertical slices of the Earth, leaving massive blind spots. They were essentially blind pioneers, operating with maybe a 20 to 30% geometric certainty. Then, in the 1980s, 3D seismic arrived, and it was a huge leap. It showed us the 3D shapes, the faults, the structural volumes with about 50 to 60% certainty. But here is the massive catch. 3D seismic shows you the shape of the rock container, but it absolutely cannot guarantee what fluid is actually inside that container. As a result, countless dry wells have been drilled into beautiful 3D structures that turned out to be filled with nothing but salt water. Think of it this way. Traditional seismics is kind of like a blurry medical x-ray. It's great at showing you the bones, right? The rigid structures. But if you want to see the soft tissue or the blood flow, the actual valuable fluids, an x-ray is totally useless. You need an MRI. Because the industry has been relying on x-rays for decades, they've literally left an astronomical amount of oil behind in mature fields, simply because their old tech just couldn't see it.
Section 3, the RSS-NMR revolution, the direct detection cheat code. Now, the good news is, science has finally advanced to cure this seismic blindness. Enter RSS-NMR, which stands for Resonance Spectral Survey combined with nuclear magnetic resonance. Now, this is not just some software update, okay? This is a total paradigm shift. Instead of sending acoustic shockwaves to guess the geometry of the rock, RSS-NMR interacts directly with the atoms in the ground. It specifically detects the hydrogen nuclei of hydrocarbons sitting right inside the rock pores. We've officially moved from guessing the shape of the trap to scientifically proving the exact signature of the fluid. And this brilliantly illustrates how much the game has changed. Traditional exploration is exactly like playing poker. You literally have to pay to see. You're spending millions drilling blindly into a structural shadow, just hoping oil is there, carrying a massive financial risk of hitting a dry well. But using RSS-NMR, it's literally like seeing your opponent's cards before you even place a bet. You get scientific, direct proof of mobile, extractable fluids before a single drill bit touches the earth. It virtually eliminates the risk of exploration.
When we take this technology and apply it to a brownfield, which is an existing mature oil field, the economic comparison is just staggering. Look at this. For a new greenfield, getting permits takes years of painful negotiations. For a brownfield, 0. You already have the concession. Time to first barrel, 5 to 10 years for a greenfield versus mere months for a brownfield, because you're literally just drilling a short sidetrack from an existing well. Capital expenditure and infrastructure costs are colossal for new fields, but totally minimal for mature ones because, well, the pipelines and roads are already built. You have complete, validated geological data instead of speculative guesses. The return on investment becomes ultra-fast. Brownfields suddenly become the ultimate plug-and-play assets.
Section 4. The treasure of mature fields. The bypassed pay phenomenon. So we have this ultimate fluid finding tech, and we have a highly efficient, fast-tracked environment in brownfields to actually use it. Now let's talk about the sheer scale of the treasure waiting to be unlocked here. 565 billion barrels. That is the official estimate from the USGS, the United States Geological Survey, of undiscovered, technically recoverable conventional oil left in the world. To put that massive number into perspective, that is roughly 15 to 17 years of our current total global consumption.
But that begs a very, very obvious question. With satellites, supercomputers, and thousands of oil companies constantly searching the globe, where exactly is all this undiscovered oil hiding?
Well, according to the USGS, about 75% of it is concentrated in these 4 major regions. Now, while areas like the Arctic hold roughly 90 billion barrels, we all know drilling up there is incredibly expensive and super risky. But if we look at the others, South America, Sub-Saharan Africa, the Middle East, a massive portion of this undiscovered oil isn't actually out in some uncharted, dangerous wilderness. The real secret? Massive amounts of this so-called invisible oil are hiding right under our feet. They are locked inside bypassed, isolated compartments of already operating mature fields. We're talking about the thin reservoirs, the subtle stratigraphic traps, and the micro-faulted blocks that those clunky 1980s computers and blurry 3D seismic completely missed. We absolutely don't need to go to the freezing, inaccessible Arctic. We just need to put on our RSN NMR glasses and look a lot closer at the fields we already own. This whole concept builds into an incredible, highly efficient 3-step life cycle that squeezes literally every last drop of value out of a brownfield. Step 1 is what operators have basically already done. Exhaust the obvious giant zones mapped by the old seismic. Step 2 is where the magic happens. We scan the field with modern RSS NMR, pinpoint those bypassed pockets of mobile oil, and run cheap, short sidetrack pipes to hook them up to the existing network. And step 3 is smart EOR, or enhanced oil recovery. EOR, which is injecting gas or chemicals to sweep out stubborn oil, is usually really risky and expensive. But because RSS NMR maps exactly where that residual oil is trapped, you only inject expensive chemicals where you mathematically know for a fact it's going to be profitable. Section 5. Smart Acquisition Strategy. The Information Asymmetry Heist. Now, when you take this scientific breakthrough and apply it to corporate mergers and acquisitions, it literally becomes an information asymmetry heist. Just imagine auditing a mature oil field with RSS NMR before you buy it from a competitor. The seller is pricing that field based on their outdated, declining 1980s data. But your modern scan identifies quick wins, pockets of bypassed oil that you can tap into immediately for fast cash flow. You map the exact reservoir extensions that the seller doesn't even know exist. Plus, you completely avoid buying bad deals, like fields that are totally watered out. You are effectively fixing a fair price and buying what the seller assumes is a dying asset at a steep discount, all while secretly holding a treasure map that proves it's an absolute cash cow. And you can scale this up to build a true smart upstream empire. You maintain a central brownfield not just for its oil, but because it gives you ownership of the export pipelines and the road to the sea. Building new pipelines today takes billions of dollars and years of red tape and environmental permits. But if you already own the hub, you simply use RSS NMR to scan and quietly acquire the neighboring, undervalued fields right along your existing pipeline route. You just plug these newly discovered, heavily discounted adjacent reserves straight into your already amortized logistics network. It is an absolute masterclass in supply chain dominance. So, we've seen how the historic plunge in EROI makes traditional exploration just way too costly. We've seen how 20th century seismic left billions of barrels behind, and we've seen how RSS and MR technology completely flips the script on the future of energy economics, turning mature, overlooked fields into highly lucrative, ultra-low-risk gold mines. So I'll leave you with this final, provocative thought. With 565 billion barrels still out there, will the industry keep gambling billions in the dark, hoping to strike it lucky in the Arctic? Or is it finally time to put on the right glasses, utilize the science of today, and claim the immense treasure already sitting right under our feet? Thanks for joining me for this explainer, and I'll catch you on the next deep dive.